虚拟背景。好，这样不好，不要背景。好。Okay, this is the first lecture, first one. And what I try to let you know is this time I forget. This one. Page. I don't know which page. Page 24 in the first lecture. Just for your reference. For a deep learning, for undergraduate student, okay, it's the relative class will be linear algebra, or probability and stochastic, and signal and systems. 大学部的这些，那比较重要 is the important one is the linear algebra and the probability stochastic. But don't worry, I will teach you. I mean, I will teach you about at my class. I will teach you, even though you don't have that kind of background, it's fine. But just let you know about this computer vision and deep learning. And for the graduate, also probability and stochastic and image processing. I said the other class I will teach you image process about convolution and then OpenCV, computer vision, and those books are important books. And this book is not easy to understand. This book, Hartley and Zisman, but both professors are very famous. And I give you the PDF file for this one. Also give you PDF file for Swirsky. And for the machine learning, actually probably those books are probably the best book. Okay, for machine learning, the Bishop, this book is very good. But so far for the deep learning, I still cannot find good book. Okay, but I give you the PDF file of this one. This book actually is not, I feel it's still not a good book. Right? So it's okay. And Goodfellow is famous. Okay. Benji is also famous. So I said three important guys for probably four important guys, include both. And the important conference or journal related to computer vision deep learning is this one, both, all of them. CVPR, ICCV, okay, and NIPS. CMU is probably not. Just 1, 2, 3, 4. Oh, sorry, 3. So CVPR, ICCV, IPS are 3 are important. ECCV and HCCV, there was some good paper there. And for the robot or related to our field, IROS is a top conference. Okay. And for the journal, probably PAMI is a good one. Not only this one, it's just some transaction. Okay. IEE, the journal in IEE doesn't mean a good journal, but transaction paper are good journal. So that's for your reference. So we delete this one. So we start our lecture 2, 0102, this one. Last time we mentioned about this one, and we'll continue. So we start from the neural network. 对吗？上次这个讲了嘛。We start from neural network. So this is a neuron, one neuron, and this input. So suppose for face detection, suppose your input image, or we call image page, is 20 by 20. So the input here, before when we do the neural network, if the image is 20 by 20, and then this will be 1D, so it'll be 400 from 11 to 2020. Sorry, 11 to 2020. So it will be 400 pixels. We call 400 elements for the input. But for the deep learning, input can be 2D or 3D. However, for the neural network, the input allows 1D here. So in the 2D image, you need to flatten to be only 1D elements or vector. So the input. So each pixel or each element, they have a corresponding weight here. We call W. So W1, suppose we have 400 pixels. So input will be 400 input here. So each input, we have a one weight, but this weight is important. It's estimate. Okay, we need to try to train the weight. So we sum here. So we summation of the weight times input x. So again, so suppose input is only 400 pixels. So this summation of 1 to 400. 20 by 20 is 400. So if x is known, you collect the image, collect the face or non-face. So image size is 400. 20 by 20. So x was 400 elements, corresponding 400 unknown parameters. We call weight, parameter weight, W. W is you will try to estimate. So we do again. So this is a linear combination here in equation format. This equation format, you sum up together. So summation all together will be here. So this will be 1. Okay. And suppose if you forget the theta, the other parameter theta. So here the cell, 那个神经元就是你把神经那些资讯传到这个神经元这里，那神经元会最触发，会有感受嘛？捏你一下你会痛嘛？感受这神经元的 output。So output will be y prime. So that'll be y prime. But before the output y prime, you have a f function. What's f function? We call activation function. It's a nonlinear function. So for example, it's a sigmoid. Sigmoid between 0 and 1， 就是一个非线性的分布。因为这是一个 linear combination 进来。那我们为了比较容易分辨，就是透过非线性的分布，把它转换到一个空间，就输出变 y。What is the theta? theta they call bias. Now bias actually is a threshold. For example, suppose I input is a phase, the page phase. So if the linear combination here, the result, okay, because W, the summation of all W probably, summation of W probably equal to 1 because you do the normalization. 就 W 你把它 normalize 成假设全部加起来400个加起来是只有1的话，那这个加起来以后 ，OK， if the summation altogether you normalize to become 0 and 1, between 0 and 1， 就是你整个加起来的结果是介于0到1的值的话，我们会做处理的哈，介于0到1的值。好，那 if your threshold is bigger than 0.5, we say that's a phase. If the summation of them is lower than 0.5, we say it's non-phase. So this threshold will be your bias. It's a theta. So theta is your threshold. But based on training, before we do that, sometimes theta we need to given. 就是以前我们有时候 given. For example, we give a threshold is 0.7 based on your experience. So if it's a 0.7, it's meaning it's a phase. If it's bigger than 0.7, we call it phase. If it's lower than 0.7, we call it non-phase. 是这个原因。所以 theta 这里是一个神经元就有一个 theta， 这是一个临界值，就是当你刺激，那刺激没有反应、没感觉，就小于 threshold； 有反应、有感觉，就是大于 threshold 这样子。啊，所以这个 summation 在一个 threshold 这样子出来的结果，再做一个 activation function 把它转换。那输出就是 y， 就是那个，所以这是一个 unit， 这是一个 basic unit of neural network，a cell， 一个最基本的单元，就这样子，就这个数学式。So the unknown parameters you want to learn, want to train is W and theta. W and theta. So like I said, like the Gaussian model, when you try to train the Gaussian model is a mean standard deviation. You calculate the mean and standard deviation based on the data you collect. The same here, based on the data you collect, there suppose 100 phase data, 100 non-phase data, you collect them. After you train, so if the phase data, your output will be 1 because it's phase. If the non-phase data, your output will be 0, y will be 0. So non-phase. Based on this kind of labeling, you try to train the W and theta. That's your unknown weight or parameter weight. So that's one cell. So we can have a multiple cells. So example, so there's 3 cells. So you can have a one layer, 这是一个层哈，这 one layer can be 2 cells or 1,000 cells. 这可以1000个元素可以。啊，这是第二层的 second layers. So for each layers, you can have many cells, but for each cell have the same, the input, output, and you have a bias, and input and output, so all together. So in this format, if you write the equation format, it's not easy to write in programming, in coding. So the easy way is this way. Homogeneous matrix, easy. So entire input is input here. Entire input is here. But last one is 1 because this is a constant term. Constant term is bias here. The output here is labeling. Output here is labeling. So suppose our class only 2 is a phase and non-phase. So we have y1 and y2. So if it's phase, y1 will be 1, and y2 will be 0. If is non-phase, then Y2 will be 1, Y1 will be 0. So we do labeling here. If we have 100 classes, we have animal, we have pig, we have rabbit, we have human being. So any label, it will be 1, other are zeros. So the labeling. So you have input, you have output, and you try to estimate using optimization process to estimate the homogeneous matrix. So those are unknown weighting parameters, include W and B. For deep learning right now, those unknown parameters will be 10 million, several million, 100 million, millions parameters， 这很大哦。你目前来讲，深度学这个参数会非常大。Okay, so in the other, this is a AX equal to B. Sorry, AX equal to B. 又掉下来了，跑不上去。OK 好。So this kind of loss original, not this one, loss function. In the beginning, about 4 years ago, most people use mean squared error. That's this one. Okay. So this is a Y prime is a estimation result. So Y prime is this one. Yj, this one is the label. As I said, the label result. Only suppose you have 100 here. I'm sorry, not 100. It's not 100. Okay. Suppose you have a class here. So only one class is 1, other are 0. So this is the labeling. And this estimation result. So Y prime equal to this one. Y prime equals to W times X. So this one, Y prime will replace by W and X. So you know X input, so you can estimate the W. So based on this one, and what's the N? N is the number samples of batch. We call batch size. 就你的批次那个 batch 有多少个 batch size here. You try to minimize this loss function. So loss function about 4 years ago, either mean square error or cross entropy. Cross entropy is meaning this is the estimation result. This is a label 1 or 0, and sum of them together. But why is it minus? Because you want to minimize the error. So it's a minus. Without minus is maximize. Cross entropy is maximize. Mean square error is a minimize. Okay. And the other issue is mean square error is continue. It's for regression. So that's why I'll keep explaining to this one. When do you use the mean square error? When do you use the cross entropy? 你什么时候用 mean square error？ 什么时候用 cross entropy？ 那一般来讲 ，mean square error when you do the regression 就逼近的地方 ，like a bounding box. You have a bounding box. You try to regression to approach. 那 bounding box 你要变小，变到一样大小，这种逼近的东西的话，你就用 mean square error. For classification, yes or no, is discrete 很明确的是与不是，那我们就用 cross entropy 这样子。所以这两个不一样，一个是 regression continue 去逼近的，一个是 discrete 是与不是，是不是这 class 不是这 class？ 一般来讲不是绝对，一般来讲是用这种方式就可以分了。好，那我们再继续。So this one, this when you study the neural network or AI, they use this format. When you study deep learning, we use this format. When we start deep learning, we also use this format. This format is the same as this one. So deep learning, we start to use the network. But this is also a network. But what I say is that we use this format. 你不要会习惯用 deep learning 的方式来表示。So this input, this corresponding weight here, right? This is the bias, the theta or B, the bias. So your summation here is it? So this part is summation of A times W plus A2 times W2. So this part is this part, linear combination. Okay. And this part plus B, this plus minus is the same because the parameter will train for you. Okay, so this part is this part, the threshold. So this format we will represent by this format in deep learning 到这里为止。So this output here will be Z, will be this one. And this bias. So Z actually will be equal to this one. 这部分是 FZ, 这部分是 FZ. So the output here will be FZ. 这我昨天补上去，我忘记写 FZ. 你输出是 Z, sorry, your output will be Z. But you want your output will project or transfer to the other space. We use activation function F. So activation function F or law is try to transfer from the original space to a new space. And this function, if we use sigmoid, is this one. Because this output is not limited between 0 and 1. Or it's not limited in -1 and 1. So we want to limit this output become 0 and 1 is like a probability. Or -1 and 1 is tangent H. 忘记怎么讲了 tangent H. So sigmoid is between 0 and 1. 那 tangent H 是一个负1到1的这个东西，这样子是负1到1。So activation function, this nonlinear, try to transfer to the other space or try to here. See, here's which because the 0.5 is if you the thing is 0.5, like my example, is phase or non phase. It's not easy for you to understand. So we hope if it's more than 0.5, we will be pushed to be close to 1. If it's lower than 0.5, we will push it to become 0. So here, not many elements here. So it's easy to distinguish whether it's a phase or non-phase. 就是说你不希望你有这线性分布的话，你输出来只是线性分布的话，那很多值都介于 0.4、0.5、0.6，对你来说是很难去切它是人脸或非人脸。那我们用 sigmoid 就是只要它大一点点，我们就把它推到人脸；大一点点 threshold 小于 0.5 就是让它压下就不是人脸，这样你比较好做分类的动作，这样子。So this one we have an activation function. But right now we use many. I mean, always sigmoid is the last one. In the deep learning, we put sigmoid in the last several layers. In the middle layer, we use ReLU. 我们在中间通常用 ReLU 来做就好，因为它有太多层了。所以 sigmoid 通常是我们都放到后面才做，一开始我们就不用，一开始我们是直接把它就是空间慢慢转换这样子。So this one become one unit for cell. This one unit in neural network, this equal to this one. So this one will be one unit for your deep learning. So deep learning is based on this unit. 这是一个 deep learning 的 unit 这样子。 最基本的架构是这样子。这提供你参考之后再慢慢讲。那我们再继续。So that's one unit. Okay. But in the same layer, actually we have many units. When I say many, is probably 40 and 64, right? 128. So the many cells at one layer. Okay. So compare deep learning and the SVM supported vector machine. Actually, they are the same. The difference is supported vector machine, we in the suppose original space here. And how can you try to separate or classify or discriminate the red one and the blue one? How can you do that? There's a nonlinear discrimination here. But this curve is high dimension. It's not easy to find this curve. So what we can do, easy way is SVM is we project this one to high dimension, very high dimension. So this is high dimension. So any sample in high dimension will become sparse, 会变成稀疏 sparse here. And in the high dimension, we use linear discrimination to separate. Okay, so the concept for SVM is based on the low dimension, based on this kernel function, high dimension kernel function, we project the sample in low dimension, project to the high dimension, and then it's easy for us to do the Lagrange and to find the linear discrimination. 就说在低纬度的时候，这条曲线是很难找到的，因为纬度太高了，你可能5次方、6次方才有这种曲线，很难找。那还不如把空间把它丢到高纬度去，然后再用一个接近线性的 separation 的平面把它分开，这是 SVM 的观念。好，那 based on this concept, how deep learning can do? Deep learning find, okay, in SVM, no matter this is complicated or not complicated, they use the same kernel function to project very high dimension. That's not good. 哦，你不管什么都把它丢到很高纬度去，那很麻烦。那这边的话怎么做？它就这个 layer 是你自己选择的，所以you don't need to have many layers. If you have more layers, that meaning you transfer to more high dimension or you transfer the different space. But sometimes you don't need to transfer to be higher or more different space. Sometimes you can be like a set the shorter layers, small layers. You don't need to be so deep. So each layer actually is kind of a space transform. 每一个 layer 是一个空间转换，你就不用那么多，这可以控制的，这样子。好，所以这个你是不是要很 deep？ 就你自己这就根据经验来的这样子。那我们后面会开始讲为什么会有 identity， 会有 shortcut 这些原因。OK。The second idea is from AdaBoost. So recent 2 or 3 years, there are papers start talk about boosting deep learning, boosting 的东西。那这是从 AdaBoost 那边弄过来的。那简单来讲是什么？这是什么东西？就是说 the same layer is kind of we call each cell is kind of a weak classifier. What's weak classifier? It's meaning if you given the here I use this one to explain. Here, page, I don't know which page, 27, right? 27, page 27. I use this one to explain. So for face recognition, for face recognition. Okay. For each layer, suppose in the previous layer, you try to extract for face the corner, the edge, right? So that for the original several layers, you extract the small features. In the middle layers, you extract some geometric information, include the eyes is above the nose is below the eyes, mouth is below the nose. So it have more something, the entire feature and more geometric information, and more higher layer, you have an entire face. So Dylan is based on this idea, this concept. So what's this concept? Back to here. So the same layer, suppose, because for each weak classifier, you can see it's one convolution, 是一个 filter. Suppose 3 by 3 filters. So this one probably try to extract your kernel, your corner. Okay. This cell is a convolution, a filter. You try to extract probably, okay, your edge. So different, like this one, probably they try to extract your eyes information, 你眼睛的资讯. This middle one probably try to extract your nose information. The lower one, they'll try to extract your mouth information. So this one, entire layer, you try to extract your detailed information, but some might extract your eyes, some might extract your mouth, some might extract your nose, something like that. So let's become, this one, we call one strong classifier. One strong classifier is combination of weak classifier. Each weak classifier only one 3 by 3 filters. A filter. And this concept is from AdaBoost. So before deep learning, AdaBoost is the best method for face detection. AdaBoost is the best, and SVM probably is the best method. Actually, one of best, two kind of best method. One is the SVM for face classification, face recognition. Before deep learning, AdaBoost is the best method for face detection. SVM is probably one of best method for face recognition. But after deep learning, they have both concepts. They beat AdaBoost and SVM. Okay, but the concept is similar. Okay, so this one is extract the detailed information. This in the deep, this part extract the geometric information. Okay, but each cell is one kernel, one convolution filter. 每个 cell 是一个 convolution filter 来萃取这样子。好，那 how can we solve the parameters W and B? We back to here, right? So here is only one cell. It's easy. We can solve W and B easy. But we become more deep. So it's page, which page? Page those I forget. Oh, page here, 13. Page 13. We have more layers. Will become this one. This output here, right? For layer 1, we have W1. There's only one cell. Okay, for this one has W2. And total, we have L layers, but this only one cell, one cell, one cell. So this kind of organization is not easy to understand. So we organize this one. So this meaning what? Okay, this is input. And inside this input, and inside input is a Wx plus B, right? And then this is an activation function, this output. So input, output, and this is a activation function. Okay, so from layer 1, in the inner one, layer 1 here. So input is X. The parameter vector or matrix W plus B. The output is an activation function law. So this output inside here, this output become the second layer input. So this output here become A. A will be the so this input X after layer 1, the output will be A1. So this A1 times W2 plus B2 will be output will be A2. Okay. So you'll find the wrap input inside and output become the second layer. The output here will be the second layer input here. So it will become wrap. So finally will become this one. So the final layer, the output will be Y. So output here will Y. Then the parameter will W. And the output here will be A, L minus 1. So it will become this one. So if we write in this Ax equal to B format here, we will find out why we need back propagation. What we just say is a feed forward. 我们刚刚讲的是从前面这样 feed forward 来写成这个。So this equation we just say is a feed forward， 就从前面这样一层一层是从这边讲过来。但是我们在解的时候 ，when we use gradient descent to solve this one, this equation, this matrix, we use a gradient descent by the back propagation. Why is the back propagation? It's here. So our output labeling is Y. 我们刚刚讲 label 要 label 1或2。Our output is Y here. So output is you label it. W is an unknown you try to estimate. X is the input of layer L. The input X is L minus 1, right? So the X, the input X also the previous output. So X equal to WL minus 1 times XL minus 1. 你的最后一层的输入 X 实际上是上一层的输出。对 ，the last output is equal to previous input W times XL minus 1. So you keep going for back propagation, keep going, you'll find your final input will be the original input X1. 你的最后输入是这里，就 X1。然后这个 W 就是一串的 W 相乘，你输出就是 Y。So this one will be based on your back propagation. So this matrix become this matrix exactly the same. So become AX equal to B format. So all the deep learning, no matter how deep it is, you'll find out based on this one. Based on the back propagation, you will find out the final result here. The input will be original, the first input X1. The output will be Y. And this matrix W will be this one. So in deep learning, you try to solve this one, will based on X equal to B problem or based on the back propagation. And this format in simple way is this one. 这注意一下哈，你会发现这个从这个输入一开始输入到这个输出 Y 嘛，那 F 是一连串的相乘，这 F 是中间一连串相乘，就一个包一个，一个包一个。那我如果用这个推导方式来写的话，你会发现整个 F 方形就是你这个 WB 方形，就你参数方形。这个那 WB 是什么？就是你的参数那些 activation 方形啊 ，linear combination 方形这样子。所以是要解这个方形。OK， 那又回到，所以我们怎么解这个方形？就用 gradient descent 方式，这我们之后再讲。所以这样就，所以记得这个 format 就 AX equal to B 的 format， 就是整个 network 的 format， 这样子，就是下面这个 format。但是你用 back propagation 的方式来解释这个，就下面右边这个叫 back propagation 的来解释这个。Now we keep it. So for the input, there are two kinds of input. If your GPU is powerful, you can input entire image to here, like a 512 by 512. Usually 512 by 512 is already in current situation is already big enough. If your GPU is not powerful, you can use a patch. So the input will be patch and input here. Not this one page, no. This one pixel. This one input pixel. So suppose page is 20 by 20, so this will be 400 pixel here. But usually not 400. Usually if this is 20 by 20, there will be here 2D. Difference can be 2D or 3D. So there will be R, G, B, R channel, B, R, G channel, and B channel. So this one. So this one page, right? Sorry, this one page, and shift one pixel or shift half and become the second one. So this is the input. And basically, if we have a 3 layers, so first layer is try to extract local feature like an edge. The second one is more large. Actually, he said corner, the favorite not corner, because first one probably include a corner. But the second one is more than corner, it's bigger. And the third one is a geometry, or we call semantics. Semantics meaning they include a geometric information, or we also call global information. Just global information. So we have local, median, and global information, and for the classification. This is for classification. So we become like this one. So the input, this is a VGG16, 16层. So input is one, 224 by 224, suppose. And we have 16 layers. And we have 5 downsampling. So usually we have 5 downsampling. So ray 1 is downsampling. So maximum pooling, 1, 2, 3, 4, 5. So become 7 by 7. So right now, after AlexNet, right now, almost all the deep learning, they have a 5 downsampling. Okay, but for between downsamplings, they have a layer, convolution layers, 去萃取它的资讯. So this is what we call convolutional network or encoder. 这是编码，因为这里就是码，编程码，所以叫编码。But for the classification, here is this one. You can use 3 neural net multi-layer for classification. So this is a network. But for like a segmentation, more detailed, you need to do upsampling. to recover back to the original size. So this is called encoder. I say again, if you only do classification， 只是分类而已的话，你只要 encoder 就好了。However, if you want more like a segmentation, more details, you need to do the upsampling. So if you have 5 downsampling, you have 5 upsampling. This is called deconvolution or decoder. 编码跟解码在这边。But when you do the decoder or do the upsampling, you will lose the information because here only 7 by 7. So when from this source, such small layers, small map, you want to recover back to the original map, you'll lose a lot of information. So even though right now people still try to figure out a good method to solve this information for upsampling, solve this problem for upsampling. 我们还在解决这个问题哦，这个还没解决完，因为你会失去资讯。OK， 好 ，we continue. But this is a convolution. 这我又讲，那这里是改成，sorry, this is a flatten， 就是用那个 fully connection， 这 neural network。Later, people say this is not good. I will explain to one later. But this one, people start to continue to convolution. So entire convolution. So they use the convolution. But doesn't mean this nobody uses it. Somebody still use this one. Most people use this one. And retina is important. What I try to say right now is here. This one. Retina here. Retina is important. This only downsampling here. Only downsampling. This one include downsampling and upsampling. Because you want more detailed information. And retina is important. So fast RCN is important, mask RCN important, and retina important. So next time I will continue to talk about the entire one. So we'll talk about retina, and then later we'll talk about a little bit about YOLO V4. I think YOLO V4 here. I'll explain to you what's the YOLO V4. Okay. So that's for today's lecture, and next week we'll continue to talk about this one. Okay, thank you. 我会把这个尽量把它解释完了，就让你就是这个图哈，我会先把这个图这整张图先把它解释完，让你对深度学习有个基本概念。I will explain to this one for this lecture. So you can have a basic concept for entire deep learning. And then after this lecture, I'll start to talk about some important network to explain to you more in details and how can you design the network, deep learning network. You can design it. Okay. So that's for today. Thank you. 那你们有问题再问一下，可以助教时间问啊，助教有问题可以问，就一起来问我没关系哈。谢谢。